All right, taking a look at number 7 from your homework. It's looking at this sailboat. They're saying that the mast is 15 meters high, right here. They're saying that the jib to the prow is 4 meters. So we're going to add that dimension right here, 4 meters. And they're asking how long the forestay is. So basically they're asking how long is this hypotenuse here. Okay? So we know that C is our hypotenuse always in Pythagorean relationship. So we're just going to start plugging in numbers. So I can take the mast length and put that in for A, 15 squared, plus my 4 meters here. I'm going to put in for B. So 4 squared equals C squared. 15 squared, I just evaluate that. It's 225 using my calculator. 4 squared is 16 equals C squared. Add those together, 241 equals C squared. Now I get to the point where I'm not looking for C squared. What I'm looking for is C. Just the length of the forestay, which is not C squared. That's the area of the square that we would build off of that. It's just the length of that side is C itself. So to get rid of this squared, I need to square root these two sides. So the square root of 241 is the same as the square root of C squared. When I square root that, that gets rid of the squared, which equals C. And using my calculator, I'll just grab the number for the square root of 241. So I used my calculator, and I got 15.524174. We're looking at rounding off to the nearest hundredth, so 2 decimal places. So I'm just going to draw my line right here, a little dotted line, and I'm looking at this number is what I'm going to round. So to do that, I'm going to look at the number next to it. So the number to the right of that line is a 4. I know that's less than 5, so I'm going to round down. So my result is 15.52, and that's going to be meters equals C. So that tells me that my forestay, my hypotenuse, is 15.52 meters, which makes sense in this triangle. It's a pretty skinny triangle, so I know the hypotenuse is going to be the longest side, but it doesn't have to be much longer than the next longest side, which is 15 meters. So it's just a hair longer, about a half a meter longer. There's your answer. All right, looking at the second question on the homework, number 8. A cable car travels 2,236 meters up the mountain to reach a height of 1,000 meters. Then it travels 1,414 meters down to get to the other side. It says a tunnel goes straight through from one end to the other, and they're asking how long is the tunnel. Here's the tricky part of this question. If you're just doing the hypotenuse, you would think this is a triangle like this, right? You look at this big triangle. But we can't do that because this is not a right triangle. What we're really looking at here is 2 separate right triangles to make up this equation. So I've got this triangle over here, which I'm going to call triangle 1, and this triangle here, which I'm going to call triangle 2. Both of these are right triangles. To get our total, what we're looking for is the leg of triangle 1 and the leg of triangle 2, and adding those two together. So we're going to work on 2 separate Pythagorean relationship right triangles here. Both of them share a side. So one of the legs is 1,000 meters. The other thing we know is here's the right angle in each of them. So opposite the right angle is the hypotenuse. So instead of having the a squared and the b squared, this time we have the b squared and the c squared lengths. So we're going to put those into our formulas. So I've set up the formula for triangle 1. We've got a squared plus b squared is c squared, our Pythagorean theorem or relationship. And then what we've got is we've got the b length and the hypotenuse. So I've put in the b length here for 1,000 meters and the 1,414 here for the hypotenuse because it's opposite the right angle. So now I'm just going to evaluate it. So we start working through this. So I have a squared, we don't know what that is. 1,000 squared is 1,000,000. And that's going to equal 1,414 squared. 1,414 squared, put in my calculator, I get just under 2 million. 1,999,396. So next I'm going to use my algebra, what we know from algebra. I'm going to subtract 1 million from both sides, because we know we can, whatever we do to one side, we can do to the other. So that leaves me, these cancel out. I have a squared is equal to 999,396. Next thing I need to do is I need to do a square root of each side. and I end up with the A length being 999.7 meters. So next I'm going to set up my other one. So I've got, again, a squared plus b squared is c squared. I don't know the a squared. We'll say that's the base down here. But I do know the b squared, which is 1,000 squared, and I know the c squared, which is 2236 squared. So that's a squared plus 1 million again, equals 2236, which I'll punch in my calculator. Alright, so we're getting some big numbers, so I have to shrink this down a little bit. What we're getting here is these, so we're going to move on with our algebra, so we're going to cancel these out. We end up with a squared equals 399696, which then again, I'm going to have to, oh, sorry, I forgot a 9 there. It's almost 4 million, which I'm going to square root again. So square root of 3,999,696. So now I've got my two lengths. So here's one length down here for triangle 1, 999.7 meters. Here's my triangle 2 length, 1999.92 meters. So I've got the one part for triangle 1 is this part, and the triangle 2 length A is this part. Now all I have to do is add them. So I'm going to take 1999.92 and add 999.7, and my result is 2,999.62 meters. Sorry for running out of space there. So the total answer, I'll put up here, 2,999.62 meters. So that's the length of our tunnel. This right here is our length of our tunnel from one end all the way to the other. Alright, third problem, number 9. A wheelchair ramp must be 12 meters long for every meter of height. What is the length of a ramp that rises 2 meters, and how long does this ramp extend along the ground? So the ramp length is telling us the slope length, the hypotenuse. Here's the right angle, so opposite it, the angled part, is the hypotenuse. So if 1 meter height is 12 meters long, so it's going to be 2 meters for high times the 12 meters long, so I'm going to have to make 24 meters. So the first question, what's the length of a ramp that rises 2 meters? It's going to be 24 meters long. So now that we know that information, we can take that 24 meters and put it right up here into the problem. So we know the hypotenuse is going to be 24 meters. So now if we go back into our Pythagorean relationship, we have a squared plus b squared equals c squared. Our a again is going to be the 2 meter height. Our b is going to be our unknown, and our c is our 24 meter. It doesn't actually matter which one's a and b, but we'll do it this way for this one. So we got 2 squared plus b squared, we don't know b squared, is c squared, is 24 meters squared. So 2 squared is 4 plus b squared is 24 squared, which equals 576. So 4 plus b squared minus 4 equals 576. Sorry, that's a 6 there. Minus 4. So b squared, those cancel out, equals 572. So now we got to take our square root of each side. So square root of each side, we have b, not b squared, b equaling 23.92 meters. So what you can tell by that is, look at the relationships here. 24 meters is the hypotenuse, and 23.92, just 8 centimeters less, is the distance along the ground. So having such a short height gain of 2 meters means that the difference between the long leg and the hypotenuse is very, very, very small. But the hypotenuse is still longest, no matter what in a right triangle. That's always going to be the longest length, even if just by a little. Alright, last problem. In this problem, we're going to be dealing with some big numbers. So what we're looking at, the airplane travels 1,500 kilometers from one end to the other, from Toronto to Winnipeg. However, it has to climb 10,000 meters. 10,000 meters is the same as 10 kilometers. So let's be careful about that. Meters and kilometers, mixing units. So let's convert that 10,000 meters right into kilometers of 10 during the first 200 kilometers. Then it descends that other 10 kilometers in the last 300 kilometers. How much distance do the climb and descent add to the flight? So we're looking for how much distance more is the hypotenuse, then the length, because this is what it's adding. Whatever the difference is between the hypotenuse and the distance on the ground, that's the additional distance it flew. The airplane averages 600 kilometers an hour. Does it add hours, minutes, or seconds to the flight? We'll look at that afterwards as a little rate one. So first we've got a couple of problems here. In the middle, so if we look at our two lengths, we've got 300 kilometers here and 200 kilometers here. So we need to find out how much is this middle part, okay? The flat part of the flight. So 200 and 300 together is going to be 500, which then if we take 1,500, subtract the 500, that leaves 1,000 kilometers up here at the flat part at cruising altitude for the plane. So that's 1,000 kilometers in the middle. Now we just have to figure out these two hypotenuses over here. To do that, we'll call this triangle 1 and this one triangle 2. Okay, so I went ahead and did this calculation real quickly. You can check it against your own. A squared plus b squared is c squared. So I took the 300 kilometers, the ground distance, as a. I took the 10 kilometer altitude gain as b. Then I squared them for 90,000 and 100. Add them together. Took my square root. I get 300.17 kilometers. So already, let's take a look at what this number means. You've got 300.17 kilometers, so just 0.17 kilometers greater than the 300 kilometers on the ground. So because this distance is so great and the altitude is only 10, this diagram makes it look a lot greater, but it's not to scale. So if this is only 10 kilometers and this is 300, we have a very shallow triangle, which means the hypotenuse is very close to that leg. There's not much difference. 0.17 versus 0.17 distance or kilometers longer than the ground distance. So very, very small distance already. I'm going to go ahead and do triangle 2 now. Okay, so again, I just plug my numbers in. I've got 200 that I use from the ground. I've got 10 kilometers that I used after I converted 10,000 meters to kilometers. And then c squared is our unknown, that's our hypotenuse. So I calculate that, 40,000 plus 100, 40,100, square root both sides, 200.25 kilometers is the length of the hypotenuse. So that's the distance the plane travels rising to cruising altitude. So how much distance does the climb and descent add to the flight? Well, the only difference is this 0.17 and this 0.25, because the original distance on the ground was 300 and 200. So I get rid of those, and I've just got those decimal places. So if I add those together, 0.17 plus 0.25, I get 0.42 kilometers added. So less than a half a kilometer is added to the length of the flight. So if it's going 600 kilometers an hour, okay, does climbing add hours, minutes, or seconds to the flight? Well, 600 kilometers an hour, and then I divide my 0.42 by that, I can find out how many hours I'm going to get. So I set up what I would do to solve the second part of the problem. So here's B. So 0.42 kilometers is the distance. Divide it by the 600 by the speed to find out how many hours it takes to climb and descend. So the time it takes to climb and descend is 0.0007 hours. So we know it's not hours that it makes. So I'm going to go ahead and multiply it by 60. So that's the same as saying 0.042 minutes. So it hasn't even added a minute on, or even half a minute. If I multiply it by 60 again, I can find my seconds. I end up with 2.52 seconds is how much time it adds. So this is how much time it actually adds, but even just looking at that number, when we look at this first part, or this little distance and this incredible speed, we already know that it's only going to add seconds on. We can estimate that, but if we do the calculation, it does only add 2.5 seconds to the whole flight. I hope this helped you. Review your homework. You can go back, check your work, check it against mine. If I made a mistake, let me know when I see you in class on Tuesday. Have a great weekend.